Alright, so we're back to, I'm sorry, I'm drawing pictures again over here. We're back for part 2 of 2, section 2.7, rates, ratios, and proportions. We have just read example 3a, and we know that we are converting 56 miles to feet and 4 hours to seconds. So we are going to set this up since we are converting two units. I'm going to put this in the middle, 56 miles and 4 hours. Alright, so I'm going to have to work both ways since I'm converting both units. The first thing I'm going to do is I'm going to set up another fraction over here, and I know that I'm taking miles into feet. So I have to ask myself, okay, what do I know about feet and miles? And I know that there are 5,280 feet in 1 mile. And see how I put miles diagonally from miles? That's what you want, okay? Make sure to put your same units diagonal from each other. So like when I work this way with hours and I'm working towards seconds, hours has to go up here because it has to be diagonal from this. So I ask myself, what do I know about hours? And we can go through minutes. In 1 hour, there's 60 minutes, and I'm not done yet because I have to go to seconds. And again, minutes has to go up here because it has to be diagonal. So in 1 minute, there are 60 seconds. So then hours would cancel, minutes would cancel, and I'd be left with, now look how this works, I would be left with feet. Oops, not the color I wanted, sorry. Let me get something a little lighter so you can still kind of see behind it. I'm left with, this is not working for me, I apologize. Let me see if this is going to work. That's not going to work. I'm having troubles. My goodness. I don't want it to be shaded. Let me try this. That's not showing up. This is becoming more difficult than it should. Here, let's try this color. Oh, and now it's shading it. Oh, darn. This rectangle is becoming a lot more difficult than it needs to be. Oh, fill color, line color. It's crazy what happens when you read the directions. Fill color, the same color as the line color. Okay, I don't want it to be full. I don't want it to be. Let me see here. I'm special. Sorry, guys. Let's see if this is going to work. Now it's going to cover up. Oh, this is frustrating. I'm going to actually have to make the rectangle myself. Darn it. Okay, I am left with feet. See, that's the most beautiful rectangle. That's better than the rectangle that the program would have made anyways, so we're good. I'm left with feet and seconds. Feet per second, which, look what my answer. I need my answer to be feet per second, so this is perfect. Now I have these series of fractions that are being multiplied. So if you remember correctly, when you are multiplying fractions, you just multiply all of your numerators together. So I'm doing 1 times 56 times 5,280. So I'm going to go ahead and multiply that out. And I'm getting 295,680 feet over. And then I'm multiplying all of my denominators. And I'm getting this. Now, remember the fraction bar means divide. So I'm doing 295,680 divided by 14,400. And I am getting 20.5 because it says to the nearest tenth. 20.5, and my label is feet per second. Alright, so that is my final answer. And let me try this again. I can try to, there we go, now it's not covering it up. Okay, so 20.5 feet every second. It says, letter B, a fast sprinter can run 100 yards in approximately 10 seconds. Use dimensional analysis to convert 100 yards to miles. Round to the nearest hundredth. And then it tells us there are 1,760 yards in 1 mile. So this time, I'm only converting one unit, it looks like. Let me outline some important information here. I'm starting with 100 yards in 10 seconds, and I am converting to miles. Okay, so I still have seconds. I'm not changing the seconds part. So since I'm only converting one, I'm just going to, I don't have to start it in the middle. I can start it just over here. 100 yards in 10 seconds. That's pretty quick. All right. And then we want to convert this yards into miles. So I got to get my other fraction bar ready, and I'm going from yards to miles. Now remember that you have to put your units diagonal from each other. So if yards is right here, I have to put yards right here. And then I have miles here. Because look, my yards will cancel, and I'm left with miles per second, which is what I want. So we know that there are 1,760 yards in 1 mile. So now I can just multiply across. 10 times 1,706, or sorry, 1,760 would be 17,600. And then if I divide that, I get, let's see, 100 divided by, it should just take off 2 zeros. Oh wait, that was the other way around. I am getting this decimal 0.005, which would round to 0.01 miles per second, which makes sense because you're not going to be able to run much of a mile in just 1 second. So for it to be such a small number makes a lot of sense. All right, go ahead and pause letter C, or sorry, pause the video and try letter C. Alright, so I set it up in the middle because I knew that I was converting both miles into feet and hours into minutes. I worked this way with miles and made sure they were diagonal from each other so that they would cancel. And I knew that there were 5,280 feet in 1 mile. Then I worked this way with the time, and I put hours across from each other so they would cancel, and I knew that there were 60 minutes in 1 hour. So then I multiplied my numerators, multiplied my denominators, and then used my fraction bar as a division symbol, and got 5,280 feet per minute. Alright, cross products. In our proportion A over B equals C over D, the products AD are equal to CB. This is pretty much what we've already discussed. I gave you a problem a while ago, like, what did I say? I think it was 3 halves is equal to 9 over 6. That's what this is saying. A over B and C over D, if you use your cross products, AD, because they're diagonal, and CB are going to be equal to each other. So let me show this to you. 3 times 6 is 18, and that should be equal to 9 times 2, which is also 18, so it works. I'll give you another example. Let's say I have 1/2 and 3/6. Again, if I'm going to use my cross products, 1 times 6 is 6, and 3 times 2 is also 6. So those are going to stay equal. A scale is a ratio between two sets of measurements. So for example, like if you're reading a map or something, you might see it like 1 inch equals 5 miles. Something like that, okay? It could be like a key on a map. A scale model uses a scale to represent something larger or smaller than the actual object. So like if you do like 3D cars, that would be a model, like model cars. It's because the original car is obviously much bigger than the model, but they're built proportionally. They're built to scale. Architects might also use scale models when they do model buildings or model structures. Architect, had to think about how to spell that. So those would be some pretty good examples of scale model. A scale drawing would be a scale to represent something larger or smaller than the actual object. So again, architects might use these also, like if they do a drawing. A map would be a scale drawing because it's drawn to represent what's actually happening. But obviously a map is going to be much smaller than the actual whatever it's representing. The map of a city is going to be much smaller than the actual city. Alright, so we're just going to solve proportions, and these should be pretty much a review for you guys. You can use your cross products, or if you recognize that one of them is a pretty problem, which we discussed earlier, you can use those. So I'm going to do 5 times 8, which is negative 40, and I know that should equal y times 2, or 2y. So in order to solve this, I'm dividing by 2, and I'm getting y is negative 20. Alright, same idea on letter B. Again, I'm going to use my cross products. So I know that 4 times g plus 3 looks like this, because this 4 has to be multiplied times all of that. And then that's going to be equal to 7 times 5, which is 35. Okay, so I am going to go ahead and distribute this, so I have to do a little bit of simplifying here. 4 times g plus 4 times 3 is 35. Then I'm going to subtract 12 from each side. So we're taking it back to that basic algebra. My lines are curvy for some reason. I'm left with 4g is 23. And then I'm going to divide by 4. And g is, now you can leave this as 23 over 4, or you can go ahead and understand that that's a 5 3/4. Alright, so now I'm going to plug this back in to my original equation. If I plug in 5 3/4, add 3, and then divide by 5, I'm getting 1.75. What's 7 divided by 4? 1.75. Okay, so just like when we solved equations, I did want to plug that back in since it was a little bit more complicated, and just double check, make sure that was right. At this point, go ahead and pause and try letters C and D on your own. Alright, so I went ahead and did letter C, and I got m equals 15. I did go ahead and plug that back in and check it on my calculator, and I got an equal statement, so I knew I did that correctly. Letter D, I went ahead and distributed and solved for the equation, and I got y is 24. And I plugged that back in my original proportion, and it came out to be true, so I know I did that correctly. We already talked a little bit about pretty problems. They can be solved using multiplication or division. So, for example, we did some before that were pretty problems. Let me give you just some quick examples real quick. Alright, pretty problems can be solved by multiplying or dividing. So here I would have to multiply by 4 and multiply by 4 to get x is 12. Here I would have to go backwards. I would have to divide by a number to get here. So I'm dividing by 3. And 15 divided by 3 is 5. So I got my answer by division on that time. Alright, example 5. A scale model of a human heart is 16 feet long. The scale is 32 to 1. How many inches long is the actual heart it represents? Alright, so I'm going to set up a helper fraction, and I have the model over the actual heart. And the model is 16 feet long, and I do not know the actual heart, but I do know that my ratio is 32 over 1. So here I had to multiply by 2 to get there. So what number would I multiply by 2 to get to 1? And it would have to be 1/2. So x is 1/2 of a foot, or you could think of it as 6 inches. Alright, go ahead and pause the video and try letters B and C on your own. Alright, so for letter B, I got 19.5, and I labeled it feet because I was trying to find out how long the actual wall is. On letter C, I set it up like this, and this time I was trying to find out how long the wall was on the blueprint. So I left the x in my numerator, and then I labeled my answer inches because it was on the blueprint. That concludes part 2 of 2 videos 2.7, rates, ratios, and proportions.